Alright, and we're live. Hello, YouTube VOD viewers, I'm assuming, at this point. A second to get chat pulled up. On the computer, maybe? Possibly. Puppy is crazy today. It's not working. There it goes. Alright, now we got you. Okay. Hey guys. Hope your Thursday's going well, and you're about ready for the end of the week. Today, for geometry, we're just going to talk about where we're at, and then we're not going to do a review. We're going to just jump into we're not going to do the review prompt, we're just going to jump into the lesson. Oh, I didn't care who. Maybe, depending on how many people we get, we'll see if we can do that. Hello! Yeah, so geometry, it's one. We're going to be doing volume of three-dimensional shapes today. So we'll talk about how three-dimensional shapes are built. And then we'll talk about how to calculate some volume. We got two so far, so we'll wait a bit more. Pull up this. Find one. Okay, so I'm just trying to find a link that we might use later. Okay. Oh, laggy. Well, that's not good. Yeah. Not dropping frames. Okay. Sorry, guys. We lost some people. Hello. So, we're going to start with finding some volume and talking about that. To do that, we are going to use the textbook. So if you have that, that might be useful. So we've got textbook, and we're going to talk about volume. So this is page, if you're following along in your textbook. And I put the student journal page in too into the Dropbox. This is page 625. So starting with the section 11. Okay, so we're in 11.5. And I'm going to skip kind of these explorations and just talk about how volume is built and then calculated. So then this is more of the formula section for for the chapter. We're going to have some volume formulas. They're going to depend on some things, depending on what kind of shape it is, three-dimensional shape. We talked on Tuesday about how to create three-dimensional shapes, either by rotating something to make a three-dimensional shape, depending on the axis. We're not just going to rotate today, we're going to kind of stretch things too to make three-dimensional shapes. And we've got lots of kinds of three-dimensional shapes. And some easier ones and some harder ones. The first difference we need to talk about is the difference between just straight vertical, like a box, like that you would get from Amazon, or a cardboard box, or a shoe box. Puppy's making weird sounds. Or slanted shapes. So things like, I have a lot of good examples of these off the top of my head, but we use slanted shapes all the time in the real world. So beams on a bridge would be one. So here we have volumes of prisms and cylinders. So prisms, remember, have polygons for sides. We're mostly worried about four-sided here, but then we'll also get into some, three-sided things or more-sided things. Okay? And so the volume is going to be the area of the base, here's our first formula, times the height of the object. And it does not matter if it's a straight vertical object or if it's a slanted object. Okay. And the reasoning for this is when you get into calculus, and you're probably in this class, at least my accelerated class, you're probably going to end up taking calculus at some point. Or the goal is that you would take calculus. The shape, example, I'm looking for an object, right? If we have this pen, and this is like a cylinder, it's right here. This is like a cylinder, basically. It's got some weirdness here, but if we just pretend it's got some weirdness in the end, it doesn't make it look something. If we just pretend this is a cylinder, well, we would calculate the area of the circle on the end here, so this area, and then we would calculate the height, and we'd multiply those two. And it's like we're stacking up little discs over and over and over and over and over and over until we get the height, and we're calculating the volume of each of those little discs, and that gives us the big disc, or the big shape, this one. You can think of it like a bunch of pennies stacked up, and I have a change jar here, but it's really hard to show you on camera. If we stacked up a bunch of pennies, we could calculate the individual value of one penny, the volume, and then we would add all those pennies together, and that would give us the total volume. So that's like what we're doing here. If we took those pennies and we just slanted them a little bit, actually, sorry, if we took all those pennies and we slanted them slightly, so it created kind of this shape going this way, it would still have the same volume as if it was straight up and down, right? So it doesn't matter if my pennies, right, this screen, doesn't matter if my coins are quarters, if they're straight up and down like this, or if they're slanted slightly, it's still going to be the same volume. And I know that's kind of far away, but you can see it better. Right? If they're like this, that's the same volume as if they were all stacked up perfectly. Okay? So the slanted formula is the same as the perfectly vertical formula. Okay? And so that formula is going to be the volume is going to equal the base area times the height. Okay? And this is going to work for any three-dimensional shape that has consistent structure. Right? So the base needs to be the same at the top and the bottom. You can't get skinnier like a cone. It has to be the same everywhere. So when we're looking at our screen, we're looking at our prism right here, this thing, it has the same base and top. Right? So we'd find the area of this thing, and then we would find the height, and that would give us the volume combined. Okay? So we can do that here with this this triangular prism. That's what we're going to do. We're going to do this first example. So we have a triangular prism. And it looks kind of like this. Kind of. This is a right angle. This is a 3. This is a 4. That means this is a 5, but we don't need that number. It's kind of like a block of cheese. Okay? And then this is 2. And we got dotted lines here to make it 3-dimensional. Okay, so we calculate the area of the base. The area of the base is a triangle, so it's going to be 3 times 4 times a half, which is 6 centimeters squared. And then this is the base, and the height is just 2. So our volume is going to be 6 times 2, which is 12 centimeters cubed. So we have 3 centimeters. We have centimeters cubed. Volume is always going to be in cubed units. Okay? So some units cubed. Right? Okay, so we found the area of the base, and we just calculate, multiply it by the height. All right, and then for this other shape, it's a bit more complicated. Oh, it's a trapezoid. Right, so trapezoid, there's your 622 in the book is what you're here on. Now we trapezoid like this. This is 3, which is important. We trapezoid, this whole thing is 14. This is 6, and then the height here is going to be 5. Okay. So to find the area of this base, this trapezoid, you do half of the height, 3, for the trapezoid, times 6 plus 14. So we're averaging the distance here. If you remember back a couple chapters, we took these corners, we lopped it off, and rotated it and made a rectangle. That's what we're doing. Okay, so this is going to be 23 times 20 divided by 2, which is just 30. That's the base. The height is 5, and then so our volume equals base times height is going to be 30 times 5, 1, 2. Centimeters cubed again. Okay. And so that's what we're doing. We're finding the volume. And if you look back here, that's what we get in the textbook. So we took the base and the height, we multiply those to get the base. It's 30 centimeters squared for this trapezoid here, and then the height is 5. We'll multiply that, and we get the total volume of the prism. Okay? The volume of the cylinder works exactly the same as the volume of prism. It's just except the base here now is going to be circular instead of a square or a triangle or a rectangle. Okay? So we're going to use base area times height again, except instead of it being prismatic, it's going to be cylindrical. So our base is always going to be a cylinder, pi r squared times the height. So this is the base area. I take my circle, make radius r, and then this thing. Okay, not the best triangle, but whatever. Okay, so the area of the circle is going to be pi r squared, and then the height would be, okay, so example. And it doesn't matter if our cylinder is slanted or not for the same justification that we used with the quarters, right? Still the same height, so use the same formula. So we're going to do these examples. I have one with 9 and one with 6. So radius equals 9, height equals 6. You get pi times 9 squared times 6, which is going to be 81 times 6, and I would use a calculator. Pi times 81 times 6, but 6 times 8 is 48. 486. Okay, and that would be in feet squared. Feet cubed, sorry. Cubic feet. Okay? And then we could do different shapes, right? Or different values. These would be in feet here. But I could change them to be centimeters. The other example that's in the book. So we'd have 4 centimeters for the radius and 7 centimeters for the height. And the units need to be the same. You may need to convert units to make the match, but they need to be the same thing. So here we would do pi squared times 7. This is pi times 16 times 7, which is 70 and 16, 42, 70 and 42 is 112 pi centimeters squared. And then you can put this in a calculator if you want to make this, but it's going to go on forever. So this is more accurate. So it'll be the volume. That's how much stuff we can put in the cylinder. Okay, so we'll talk about will we get to surface area today? Maybe. No, not surface area. We would maybe get to surface area eventually, but we're just plugging stuff in. And normally, now I would make you would go on Khan Academy and do some problems, do some stuff. So I think that's it for today. Really, you're just plugging stuff in to find the volume. You could go the other way. Nope, not really worried about that. Okay, so we're just plugging in for those, and I think that's it. And I'm not going to give you practice. Well, actually, no, I will. I'll give you a practice soon. But if you have any questions in the chat, I haven't seen anything really said hi or hey. Man, my quality is really low. I wonder if it's my camera or if it's my internet. But if we have questions, we can ask them in the chat. I think that's it. We're going to do a Zoom call tomorrow at 1. I know we only went for 15 minutes today, but I didn't do a review because I didn't want to. And kind of a short lesson. We're just doing volume, which I think we've done before, probably in you're plugging stuff in to find volume. Remember, volume is how much stuff we can put in a thing. So like the volume of this glass is how much water can I put in this glass. How much water can I put? That's what volume is. Okay. Having numbers for those things is useful. Knowing how much milk is in a milk carton is useful, so you don't get ripped off. Okay. The puppy is asleep, so we're gonna leave her be. I think that's it. I will be going through the YouTube channel and fixing the titles on things so that we know which is which, including today. We know it's short. After tomorrow, I'm going to reevaluate our time because we're getting like 4-ish people. And that does not feel like an effective use of time. It's also, of course, I'd like to go shorter. But, So if you have any questions, the chat's super useful. You can always send me a message on Remind or email. I will be putting in grades. I've gotten a few things. I got a project or two that people sent me that I haven't put in yet, and I think that's it. I'm not really sure if I'm forgetting anything. I think that's everything. Yeah. Oh, practice problems. Right. So if we go back to this screen, if you go in your textbook, this is page 631. Okay. And we would do 3 through 10 here. 3 through 12. So 631. Okay, so you get something. So, those are the practice. 631 through 12 would be the practice. Okay, and I'll send a reminder. I forgot to last time. Okay, I will see you guys tomorrow. I'll send an email later today with the Zoom information. There will be a link in there and a password and stuff that you can use. And I think we'll be good. Not seeing any questions in the chat. A lot of silence, so I'm assuming we're good. Yeah, and if your parents or anybody has any questions, just let me know. Okay, I'm busy watching the puppy, but doing projects, but I got time for you. Okay, so good to talk to you guys, and I will see you